All right. So in this video, I'm doing AMC 10B 2021 Spring, problem 19. Suppose that S is a finite set of positive integers. If the greatest integer in S is removed from S, the average value, arithmetic mean, of the integers remaining is 32. If the least integer in S is also removed, then the average value of the integers remaining is 35. If the greatest integer is then returned to the set, the average value of the integers rises to 40. The greatest integer in the original set S is 72 greater than the least integer in S. What is the average value of all the integers in set S? Wow. All right. I'm not going to lie. This problem is just a lot of annoying algebra. So just bear with me. Yeah, that's pretty much it. Just a lot of annoying algebra. I don't know how else to put it. So I called the sum of the values in S, just to give it a name, right? So when I write S, it refers to the sum of the value, all of the values in set S. G is the greatest integer in the set, L is the least integer in the set, and N is the number of integers in the set. So the first thing tells us that the sum take away the greatest number divided by N minus 1 would equal 32, right? The second tells us that if we took the sum minus the greatest and then also minus the least divided by N minus 2, that would equal 35. And then the third equation tells us that if we put the greatest back, so we'd be left with S minus L, divide by N minus 1 would equal 40. So we know these three equations, right? And then we also know that, well, this will work. Okay. We also know that, let me just make this a little bit, yeah. G equals L plus 72, right? So we know that as well, which allows us to do some substitutions. So from this first equation, if I substitute G with L plus 72, I can rewrite it as follows. I can write it as S minus L plus 72 equals 32 bracket N plus 1. N minus 1. Right? So by substituting G with L plus 72 and then cross multiplying, I would get this, right? For my next one, I would get S minus L plus 72 minus L equals 35 N minus 2. And from the third one, I would get S minus L equals 40 N minus 1. Now, notice how if I take which ones? If I take the top equation and the bottom equation, so let's say equation 1 and equation 3, right? And I subtract them from each other. So I subtract equation 1 minus equation 2. Or actually, what I could do is if I take equation 1 and I add 72 to both sides, I get S minus L. So just rewriting this would be S minus L equals 32N minus 32 plus 72, or S minus L equals 32N plus 40, right? So I can rewrite that top equation as being S minus L equals 32N plus 40. So now if I take this equation and I subtract this equation, or set them equal to each other because they both equal S minus L, I get 8N equals 80, which tells me N equals 10. So now I know N is 10. So now what I can do is by plugging in N equal to 10 to each of the things, right? So what do I have? I have S minus L equals 32 times 9 plus 72, right? The next one I get S minus, whoops, sorry. So that's equation 1, right? Equation 2, I get S minus 2L equals 35 times 8 plus 72, right? Yeah, plus 72. And then the third equation is S minus L equals 40N minus 40 times 9, right? But now notice how if I subtract so again, I'll call this like 1, 2, 3. If I subtract equation 1 minus equation 2, I get L equals 32 times 9 minus 35 times 8, which is equal to 8, right? So I know L is 8, right? And now knowing that L is 8, I can then substitute into the third equation, right? S minus 8 equals 40 times 9. 40 times 9 is 360. So S equals 368, right? But remember, N is 10, right? So the average, S divided by N, 368 divided by 10 would equal 36.8, which is choice D. So like I said, just a lot of annoying algebra, right? Not a particularly fun problem. Just, just got to keep track of your algebra, systems of equations, try to eliminate variables by setting as much equal as possible, right? You're going from like 4 variables down to 1. So pretty tricky, but overall not the worst for problem 19. Once you start hitting like 19, 20, like some of those problems can get pretty brutal. So this one should be reasonable to solve. So, all right, in my next video, I will do number 20, and I hope to see you guys in my next video.